Hey, geometry students, welcome to our lesson 6.5 on special parallelograms. By special parallelograms, we mean rectangles, rhombuses, and squares. And so we're just kind of looking at investigating how can we prove that we have those special parallelograms and how can we tell the difference between them. In particular, paying attention to the diagonals, and that looking at the relationship of the diagonals of the quadrilateral or the parallelogram, you can quickly identify which type you're actually dealing with. And in fact, we'll look at how to do that on the coordinate plane especially. And so because we're still reviewing the same shapes, the rectangles, rhombuses, and squares from 6.4, there's no definitions in this lesson. There's simply three questions. And so the first question is, how can you prove the type of quadrilateral using the diagonals? So how can you, just by looking at diagonals, know whether you have a general parallelogram, a specialized rectangle, specialized rhombus, or even a square? Well, we've already talked about the characteristics, but let's just put that into application. If you have a parallelogram and you have these diagonals and they are bisected, and that's the only thing you know about them, so this half is equal to this half is equal to that half, then that's the most basic type. That is an attribute of just a generic parallelogram. And so if all you have is bisecting, then you have a general parallelogram. Oops, one R. Oops. Okay, from that, you can have more complexity to the diagonals if you have a set of diagonals, and contrary to the picture, but we know that that they are perpendicular. If the diagonals are perpendicular and at a 90-degree angle, so perpendicular, if you remember, that is an attribute of, very good, a rhombus. So if they meet at 90 degrees, you have a rhombus. If, on the other hand, you have diagonals, and the two diagonals are congruent. So they do bisect each other, just they do with the rhombus as well, but they also cut each other into four congruent pieces. So in other words, the entire diagonals are congruent. So congruent diagonals, then you know that you have a rectangle. And then if you have diagonals that do all three of those things, they bisect, they're at 90 degrees, and they are all congruent, then you have the third type of parallelogram, and that is a square. Actually, what we'll do here, that is if they bisect, they're perpendicular, and they are congruent, then we have a square. Okay, so you want to start memorizing that and identifying it, because diagonals alone are the clue that are the only clue you need as to which type of parallelogram you're dealing with. Okay, and so let's look at that on the coordinate plane with the next two questions. So number 2 says, how can you check the distance between 2 points? How can you know if lines are perpendicular? Now, before we just remind ourselves, because you know how to do both of those, we've covered it since chapter 2, why do we care? The reason we care is if you're given a shape like the one I've drawn here and they ask you what type of parallelogram is it, well, you can do what we've just been talking about. We can look at the diagonals. And so if I have diagonals here, we're going to do this with actual numbers in number 3. But if I look at these diagonals, the two things I can check is the distance. So how far is it? How long are these lines? I'm going to go ahead and label these A, B, C, and D. Whoops, D, not B. Okay, so so the question is AC congruent to BD? That's one of the questions you can know. And by finding the distance between A and C and the distance between D and B, you can find out if they're congruent. Because if they're congruent, going back to what we just said, congruent diagonals mean I'm either dealing with a rectangle here, or I could be dealing with a square. And so how the diagonals compare to each other is key to knowing what type of parallelogram you have. The other question that you want to know is then the slope. What is the slope of AC perpendicular, or what we would say is of AC, is it the opposite reciprocal of BD? Okay, M there being the slope. In other words, if the slope of AC were 3, is the other slope negative 1/3? Because that would be an indication that they're perpendicular. And so again, if they're perpendicular, I know they're a rhombus. If they're congruent, I know they're a rectangle. If it's both, it must be a square. If it's neither, it must be a parallelogram. So take what we talked about number 1, and if it's on the grid, we need to be able to prove that using finding distances and also finding slopes. And so for distance, because the question asks, how can you check the distance between 2 points? The first distance, whoops, let's get my pen back up. Distance, you just calculate rise over run. Oh, I'm sorry, not rise over run. Getting ahead of myself. No, you just calculate, you want to use the Pythagorean theorem. Okay, and I'm going to do this in question number 3, but you want to figure out, okay, here's my horizontal change, here's my vertical change. Let me calculate that diagonal or hypotenuse distance, a squared plus b squared equals c squared. That is how we've been finding the distance between 2 points. To find the slope, I'll put that right here, that's where you just simply calculate rise over run. Okay, you check the vertical change over the horizontal change, and then you should have the relationship of one slope should be equal to the negative reciprocal of the other. If so, then you have perpendicular diagonals, and therefore you know what type of parallelogram you have. Not something you're just going to want to guess on, and the questions might even ask you to prove it. Okay, and so let's demonstrate that with question number 3. So question number 3 says, are PR and QS congruent? Are they perpendicular? And again, the reason we care is because if they are congruent, then I know I have some type of rectangle. If they are perpendicular, which you can see just by my sketch, it doesn't look likely, then they are a rhombus or square. Okay, so let's remember how to do this. So let me just put the coordinates on here. P is negative 5, 2. Q is 4, 5. R is 6, negative 1. And S is negative 3, negative 4. Okay. Now the easiest would be the slopes. And again, keep in mind we're doing the diagonals, not the sides. So we're doing the blue lines. So let's check the slopes. And I'm just going to do that. I could do it by subtracting the x's and the y's. Since it's graphed, I'm just going to count it out. So let's do PR. So PR, to get from P to R, I have to go down 1, 2, 3, and I'm going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So PR, let's put it up here. PR is negative 3 over 11. Alrighty, so that means for it to be perpendicular, my other slope would have to be positive 11 over 3. So let's see what QS is. So let's count up to get from S to Q. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, that's what we thought. And I'm going to go over 1, 2, 3, 4, 5, 6, 7. So its slope, a rise of 9 and a run of 7. So the slopes are not perpendicular. So this is for sure not a rhombus and not a square. So it's either just a regular parallelogram or it is a rectangle. So now we need to know, well, is PR congruent to QS? And so that's going to come down to distances. So not perpendicular. Like that. All right, so distances, and we can see, having already counted out the slopes, finding the distances, I'm all set to do that. Let's go back to start with PR. It's a triangle, basically. It's a triangle where we said it went down 3 and it went over 11. And so now we can use Pythagorean theorem to calculate that. 11 squared plus 3 squared equals c squared. Just going to grab my calculator. You're fine to use that for your square roots. Okay, so 3 squared plus 11 squared. Actually, let me do it over here. 3 squared plus 11 squared equals c squared. So that's 9 plus 121 equals c squared. That's 130 equals c squared. And so c is the square root of 130. Let's go ahead and just calculate that roughly. Square root of 130 is 11.4. Okay, so let's check QS and see if they're in fact the same distance. Which, even though your legs are different, your hypotenuse could still theoretically be the same. So let's find out, but I'm doubtful. So let's see. So the other triangle formed is one that we said it was up 9 and it ran 7. So that means we're going to do 9 squared plus 7 squared equals c squared. So 81 plus 49 equals c squared, which is going to be 50. 50 plus 30. Oh, we get 130. Okay, so c again is the square root of 130, which we now know is approximately 11.4. So yes, they are congruent. And so now we can know for sure that PQRS is in fact a rectangle and not a rhombus as well, not a square as well, but it's a rectangle because it has congruent diagonals. And again, just using the skills that we've been using ever since chapter 2, and hopefully getting you more and more confident in using those skills. Sorry, my picture was blocking some of the math there, but I described it. So characteristics of parallelograms, the special parallelograms, rectangles, rhombuses, and squares, and that the diagonals are the key, or can be key, or a key way of identifying and distinguishing between them. And we can even do that on the coordinate plane. Okay, see you in class tomorrow, and make sure you take the quizzes, and we will have a great time with our quadrilateral friends. All right.